make sure it's displaying the correct way. I have a fun mirror plugin that I need to probably disable. I think it only shows at my end. I'm not sure how often it correctly shows at your end, but one step at a time. All right, I'm going to jump back over to our algorithm. So what we need to do is we need to think our way through what is it that we're actually going to do. Well, the code is going to ask the user whether they want a gluten-free bun or not, or gluten-free bread. I guess this is lettuce is going to be used for the gluten-free, so it's going to be a lettuce wrap. So you have to figure out what's going to go into this. So whether it's going to be wheat bread or lettuce, then it needs to be able to output the numeric sequence for that. So there's 3 pieces to this process, and the flow chart is the first step in that. So we need to start by asking the user whether they want gluten-free and then what their choice is for the ingredients. And there's a couple ways to think this through. So let's take a look at how we go about developing that. So we're going to switch to this one. Try and zoom in to make this a little easier to see. So we're going to change this to be make me a sandwich. There's plenty of entertaining memes in this category already, so I don't need to make any new ones there. There's going to be a couple steps in this. We need to be able to output to the user a question, and then there needs to be some decisions made. So for most of the rest of this, we actually don't really need all of the pieces here in the middle. There are going to be some decisions, but we have to look at what are some of the options and how many different arrows and things we can use. There's a lot of examples that we can reference. So there are going to be some decisions made. In the first step, we're going to have to do an output to the user. So it will automatically move. Sometimes it will automatically move these arrows. Sometimes we'll have to add these arrows back in. So we'll bring this back over to our output, and we've got a question out to the user. So what we want to do for this is simply double click in here, and we want to say, okay, I need to ask user about gluten-free. Okay. Yeah, hyphen because reasons. There we go. Got a couple people having connection issues still. All right, so we start Make Me a Sandwich. We first ask the user about gluten-free. So this is where the actual output goes. So do you prefer gluten-free? You can also change the sizes of boxes and things more easily in this one compared to some of the other software, and Visio is just not as nice and clean for these generally. So something to keep in mind. If no, then what we want to do is thinking about the requirement. And I'm not going to go all the way to the detail of using the numbers, but we're going to do that for, we're going to keep it to text for simplicity on the flow chart. What you're trying to do is, if they prefer gluten-free, no, then here. If they prefer gluten-free, then if it's no, then you go to the next question. But first step to that is store. So I'm actually going to change this to a rectangle because this is another step process. So store wheat bread to bread variable. So we have some bread variable, could be bread type, something like that. So it could be bread underscore type or something like that. Something that, again, is meaningful. So we want to pay attention to what we're doing for these things, how those work and how those operate. If yes, then we have another step in here. So
Professor, I believe you're still sharing the instruction slide.
there we go.
Thank you.
Yeah, there'll be a couple switching back and forth, so we'll keep an eye on that. So we've got ask user about preference. Then we do the action. So this is the actual decision tree. So this is input from the user. So we need to know that we need to do a print of the question, input from the user. If no, then store wheat bread to bread type variable. If yes, then what we want to do is bring this up here so it's shorter. Plug this in. Bring our next steps here. So this end state, we're going to use it, but it's going to come up much, much later. So we're not going to use that right now. We're going to move this stuff out of the way here because we need to think through the way that this is going to work. So if yes, store lettuce to bread type variable. So fairly straightforward so far. We've started with, this is our algorithm. We ask the user for input. We ask if they prefer gluten-free. This is the input step. So you have to know that there's a step where you're asking. So there has to be a line of code addressing that. Then you actually take the input and do something with it. If no, store wheat bread to bread type. If yes, store lettuce to bread type. Okay. Then, and there's a couple different ways to arrange this, but the next step is going to be another operation that we need, and we need to say, going back to our inputs here, so we need to then ask for their choice of main ingredient. So what is the main ingredient? Turkey, chicken salad, salami, or cheese. In this case, it's very simple. So an example output might be wheat bread, chicken salad, and wheat bread, and that counts as a sandwich. The question is, what happens when you have that guy who always votes turnip and he wants turkey, chicken salad, salami, and cheese? Any ideas how we would handle that in the flow chart? What might that look like?
Can you restate the question?
Yeah. So we need to have a prompt that says what main ingredient do you prefer? So we've got one more arrow. Actually need just a step. So what main ingredient do you prefer? So this needs to be an output to the screen, and then we need the decision tree. So the question is going to be how far that goes. Yes, that's a good way to handle it, because that will be a more robust program. So what main ingredient do you prefer? And then ask for which of the outputs is possible. So you say list main ingredients. So we list the main ingredients, and from here we go. So I'm going to give you guys a couple minutes here to work on one of the next steps. Make sure that's in line. So list the main ingredients. So it's going to be a tree. So I'm going to give you guys a few minutes to start working on what that might look like. It's going to need to come down to the next level. So I'll give you a few minutes to kind of work on that and chew away at that. So let me pull these up. I'm going to open breakout rooms for just a few minutes here. So I'll let you guys give that a try, and then I'll come check out what you've got for options here in just a couple minutes. So I want you guys to see if you can get that decision tree made. Mhm. Mhm.
Hello? Can you hear me?
Yep. Yep.
Hi. Sorry, I didn't join the breakout room so I could ask you a question.
Okay.
Did you see my Halo message from last week at all?
I have not yet. I'm trying to get caught up on messages. It's been a little bit on the chaotic side at this end, so I'm trying to slowly unwind that.
No worries. The
Let me
gist
see
of
if I
it
can-
was that my I'm sorry. The gist of it was that my Playground Express was being processed by GCU Mail Center
Okay.
over the weekend when they weren't ready to give it to me. So I was
Okay.
able to get it yesterday,
Okay.
and I'm able to submit the assignment today.
Yeah.
So that was
As
basically it.
far as like assignment turn in, I would say just get stuff turned in. basically as you're able to. So I wouldn't worry about right now the late points because of the delays and things in the mail, that stuff that's not inside you guys' control. So I haven't filled out zeros for stuff that isn't turned in. I'm just trying to get you guys all caught up.
Sweet. Thank you. I appreciate that. I was really worried about it over the weekend.
Yeah, no, understandable. Good questions. Yeah, but let's focus on moving forward instead of being what's dumb butt say, being burdened by what has been or whatever that quote is. Yeah, let's focus on moving forward. That'll be great.
Awesome. Sounds good. Can you put me back in the breakout room? I pressed no,
Yeah,
so I could
you
unmute.
You should still have. Oh yeah, because it looks like you aren't in that group yet. Okay. Yeah. So let's drop
Thank you.
you in. Let's see. Should be. Go. Yeah, you should still have the option. I'll move you back and forth and see if that saves. That should give you the option still. So at the bottom, you should be able to pull up breakout rooms.
Awesome. Yeah, breakout room 5.
Yep.
Okay, sweet. Thank you.
Mm, It's a problem. All right, we're gonna bring everybody back here. All right, should basically all be back now. Good. So what we're looking at here is just wrapping this up. So I started with the part we've talked about already, selecting a bread type and then a main ingredient. So we list main ingredients, and then depending on which one they pick, so multiple choice style, then we would store that variable to main ingredient. Then we would go to the next step where we'd ask if user prefers a second ingredient. So we list second ingredients. Ideally, this list excludes the first choice, but again, there may be a guy that wants just like a quadruple stacker turkey sandwich with nothing else on it, and that's fine. Or maybe somebody wants so much chicken salad that you can't really hold it between two slices of bread. Again, that's why there's 31 flavors, and some of them you may not like, and that's okay. So look for preference on a third ingredient. Sometimes it works really well, sometimes not so much. Yeah, good enough. So then second ingredient is going to store to another variable depending on what's input. Ask if users prefer a third ingredient. So we list third ingredients and we limit at 4 ingredients typically. So third ingredients. So this to third, because ideally once they've got 4 ingredients, there's no more room. Even if they want more, it physically won't fit within the constraints of the sandwich container. So third. There was such a think ingredient. We'd probably be short on that today. Think ingredients. We're not quite ready for end yet. And then check in some capacity for a fourth. And this one is more complicated than strictly necessary to be able to accomplish the task. However, this fourth ingredient will be the last one. Fourth ingredient, store to fourth ingredient. Fourth ingredient and fourth ingredient. So this is another approach to this. And then we output to this is the display of selections to the user.
Wait, so why would they be labeled fourth ingredient if we're listing the third ingredients?
So this one is fourth because this last piece didn't get changed.
Oh, okay, okay.
So I'll walk you guys back through what this looks like. Display selections to user, and then this is the end of our program. So this is a linearized version of this process. There are other ways to do it. You can do more yes and no questions, but this is an example of how to lay this out. So program name, make me a sandwich, ask the user about gluten-free preference. If no, go to next step, storing wheat bread. If yes, store lettuce to bread type. And the step down here where we're displaying the selections to the user, there's arguably an ordering step that probably should go in here. So we would move these down ever so slightly. And the ordering step would go right in the middle of those and say we would The variables would help if it was spelled correctly. Variables, so linearly order variables. Starting and ending with bread type. So we would order those, then display selections to user, then end, is really a better way to close that off. So the steps in the meantime are, after we've selected that first gluten-free, what's your primary ingredient? So at each step, you need to make sure that you're sending an output to ask the user for input. Can anyone see what this is missing? So right here at the second ingredient.
If they
No
don't
answer.
Are you
want the
missing
second
cheese?
ingredient?
So there's a whole lot of word salad there, but we didn't quite get to the answer. Can anyone see what's missing there? Is that the complete list of choices?
If the person doesn't prefer a second ingredient, it should go somewhere
Aha!
else.
Because there's always someone trying to vote turnip. That's why, right? It's an old internet joke. It's perhaps a little too old at this stage in time, but it gets the point across. So we have another one that goes this way and says, no thanks, right? Where does no thanks go?
All the way to the end.
And not quite to end. Close, but not quite to end. No, this one. This one. There we go. So all the way to end. This one we're going to bring back so it sort of still makes sense. So this one goes back to linearly ordering the variables, starting with the bread type, not all the way to end. So,
Shouldn't it go to cheese?
so
Cheese.
it should go to cheese, but in this case, because of the way that I've listed it out, I've asked them about the bread preference first, then I'm including cheese in the selection of meats as well, in case they're just looking for grilled cheese. So list the second ingredients, and no thanks is an option. So no thanks comes off to the side here and goes down. Same thing happens here. Ask users if they prefer a third ingredient. No thanks goes here. Fourth ingredient. No thanks. Again, ties into here. Now we have a robust algorithm, because if some individual says, okay, I want gluten-free, yes. All right, so I get lettuce. Do you prefer a main ingredient? Cheese. Ask if you want a second ingredient. Cheese again. Ask if you want a third ingredient. Cheese, still some more. Ask if you want a fourth ingredient. Cheese, still again. Okay, now we're out of room in the box. And so it's just a block of cheese and lettuce. And maybe for somebody that's delicious. And so then we display end selection to the user, and then we're done with the program. But equally, somebody gets in and they're like, I want chicken salad. And then they come down, second ingredient. Nope, nothing else. Then it brings it down to linearly ordering, displaying, and end, right? So now we've accounted for all the possible combinations of things. So we've taken what was originally a very simple assignment of making a sandwich and accounted for all of the options to vote turnip. The real question is, are we missing a selection here at the main ingredients?
No ingredient?
Yeah. What about that condition? Has anybody ever ordered a sandwich without any ingredients? It's happened in history. So if somebody wants no ingredients, we need to be able to account for that in the algorithm. So for turnip guy, we need to be able to bring it. No thanks. Because if somebody just wants a wad of lettuce or toast, right, that's going to be in the no thanks category. So
What if they want no
Now-
sandwich?
if they want no sandwich, well, they're at the wrong kiosk. So if they want no sandwich, we're not going to have an output for that. You could do a check at the first step and say, do you want a sandwich? Yes, no. And go this way. And then no would come all the way around to end. And that would bypass the whole algorithm. So you could include that as an option. But normally, if someone's walking up to a kiosk for a sandwich, we're going to operate under a base assumption that they've understood that they're going to order a sandwich from a sandwich kiosk. Right? Now, given today's day and age where people are identifying as like Cuisinarts and Wolves and whatever else, jury's out on them making a better idiot. So some people can't be helped with logic, and those people probably are not going to fit well into an algorithm. So, all right. Any questions on this? Is this making sense? Anybody having the sensation that this makes absolutely no sense whatsoever? Let's
How
do the
particular
For
does
the
the language
assignment-
have to be?
Oh.
Sorry, Gabe.
You go
How
ahead.
particular does the language have to be for store lettuce to bread type variable and like that, like all that stuff?
so
It,
it-
are
it
you
doesn't it doesn't have to be super specific always, but you want to have enough information in there that you can envision the way that you would translate that to code, because the flowchart should be sort of on the edge of pseudocode in order to make sense what you're going to be doing with it. Because code is not really supposed to be super duper human readable. It's supposed to be like a translation. It's something that you want to have as much information available in there as you can, so that when you note for yourself to store something to a variable, that's a really good key of, okay, yeah, that's the next thing that I need to do in my sequence of code. If you just say, move on to the next thing, and you don't have some of those boxes for those steps, it's very easy to skip over something like, oh yeah, store that value to memory, or in the case of much more complicated algorithms, store a new value to memory because halfway through they changed their minds and went, oh no, I don't want mayo. I hate mayo on a sandwich, right? Because there's those people too. And so there's all sorts of things. I broke this process the other day at Fuddruckers, which is why it's actually funny, because I was putting together orders for cheeseburgers for all 5 humans at the table, and cheese had not gotten included. They cannot go back and add cheese to a burger that's already in, so they have to start over. So their process has not been designed to be robust. Whereas, like, if you go to Chick-fil-A and you're like, oh yeah, that second sandwich, no lettuce, add pickles, add cheese, and also all the Chick-fil-A sauce you have, right? Like, pull a Ron Swanson there. I want all of the breakfast foods. Chick-fil-A can account for those alterations after an item is entered. At Fuddruckers, you got to blow up the order and start all over again. If you didn't include cheese, then you weren't smart enough to get the burger you wanted in the first place, right? So this is a real process that has to happen when you're inputting stuff. And this is like, I think even In-N-Out is a lot more robust in their ordering processes, probably because Californians want everything custom, whether it should be or not. It's just a thing. So some of these groups have a little better customization in their algorithms than others. But that's why you need to be able to think about running them through a logical process that captures more than 90% of the use cases. So something like this works that you don't have to do it exactly this way. You can go through and simply do yes or no questions. And in fact, that would be a much shorter flow chart. But in the coding itself, if you're basically copying and pasting the same code block for an input output store to a variable, it's a simple matter of copy paste for a total of, you type it up once, you copy paste 3 more times, and then I have my code filled out. So I'm thinking about how to make the coding side easier as I'm building out the flowchart, and that's the reason why it's this way, because that whole section of code here, this block in total, is a simple, easy copy paste all of those lines. I change a couple words in there to change the variables, and the process is the same. So I can even do that in a loop, changing the names and some things like that. So there's a lot of different ways to actually even implement this code the way that it's put together here. So for me, I'm thinking in terms of loops and multiple choice stored to multiple variables, because for me, that's an easy thing that makes sense. Some of your algorithms are probably going to look quite a bit different than this, and that's actually an okay thing. I just want to show you a way of thinking about this, and how to start thinking a little bit into what am I going to do with the code. So that specificity is actually a really good question. More questions?
Yeah, so I was going to say, can we just put like a loop function at the end of this? So we say just go back up to the top and ask if they want an ingredient again.
Mm-hmm. Yeah, and in practice, that's a really simple way to implement something like this. Is ask if they want another ingredient, rerun the same list, store it to another variable with a name index or something, right? There's a lot of ways to handle that kind of process in sequence. So those are things that I think are going to help make a lot of sense overall. So yeah, there's some options for sure. And we'll get into more about loops and some of that fancier stuff before long. We're just trying to make sure that we're understanding how to start thinking about getting from point A to point B in code right now. So we're going to work on this week how to take this concept and then implement it in code using kind of a couple different varieties. Okay, other questions?
Is this like essentially what we're doing for the assignment?
Yeah, this is essentially what you guys are trying to put together. So like I said, this isn't the pattern of exactly what I expect to see, as long as you are minimally accounting for taking into account a selection for ingredients and then outputting the results. That's acceptable. So there's already been a couple folks that have been working on this part of it. So all three of the assignments this week are all related to this concept. So the first step is trying to put together a flow chart that kind of helps to make sense of all of this. Then the next steps include starting to put this to code, starting to put this in, what that step looks like, what kind of functions and sort of moving pieces you need to be able to implement that. So there's a lot of little stuff that we're going to learn along the way for this. All right. So let's do our clarity scale check. So on a scale from 1 to 10, where 1 is like dirt with no water, 2 or 3 is like sticky mud, and then like really wet mud. Then you have somewhere in like the 4 or 5 range might be like OG Gatorade flavors. Then you got like Crystal Light, and then at the very top 10 is like holy water. Where are we at? All right, good. We're seeing lots of fairly high numbers. That's good. Probably only got 5 or 8 people asleep, so we're doing pretty good there. All right. So seeing pretty good numbers. Yeah, we shouldn't be doing anything that's super duper extreme just yet. But we can go to start thinking about how we would code this. All right. Good. So we're seeing pretty good numbers there. What I want to do next is I want to think about, let's see. We're going to jump over to Arduino and start looking at what that code setup might include. And this will help to kind of get us to think a little bit about how this process works and how we go from flowchart to actually putting code into place. So pull up the flowchart as a reference. All right. So what we're going to focus on next is code. So this is the scariest thing in the universe. it's a blank coding sheet, right? So this is the thing that lots of students have plenty of nightmares about. It's not actually all that scary. So where we want to start off is we want to start off by doing our setup. We want to start with a couple of comments so that we're going to have some reference points. The comments are going to help kind of set what we're doing for each section. So this is going to be make me a sandwich. An algorithm for culinary perfection. All right. First thing that we're going to do is we know we're going to need some variables. And because we're using numbers, integers are going to make the most sense for some of these variables. So we need to note what we're going to be doing for this step. So the comment should be something like set up variables set up sandwich variables. So we do an integer for the first one. We did bread type. So integer bread type, you can technically leave this as a definition and it will understand that this is a variable and it's an integer. It doesn't have a default value, so it'll assume a default value of 0 for most things. So you want to get in the habit of doing a default value so that that can happen. So default bread type. But for this one, because we're going to be assigning those values in the actual program, I'm not actually going to be worried about what the initial values are for these. So bread type, then we need main ingredients. Main ingredients. Then we need main ingredient. We're going to do singular. Second ingredient. We're going to do another one. Third ingredient. Fourth ingredient. All right. So those are the minimum variables that we need in order to run this specific kind of algorithm, right? So are we missing anything in this list? Bread type, main ingredient, second ingredient, third ingredient, fourth ingredient. So we should be covered in terms of baseline variables for what we're attempting. Okay. Second step, in the event of something like an unfortunate computer crash, etc., we want to go ahead and include this. So this is going to be sandwich selector. Very important when you are naming, because of reasons. use underscores instead of spaces in your sketch names. Just, yeah, don't ask questions you don't want the answer to. Okay, so void setup. We're going to do a couple things here, and we need to figure out some of the pieces there. So what are we looking for in the setup? We need to do stuff with the variables. So we want to start by what? We need to do some sort of an output. Well, okay, we haven't done a lot of output yet. So we need to start by outputting the we want to output the question. So output spread type question to user. So there's a couple features that we need. And the place that we're going to learn about how they work is we're going to make use of the language reference because that's going to be helpful. Let me find where that is listed. There we go. Documentation, language reference. All right. So there's a couple varieties. There's in, let's see. Do they have them listed? It's not under analog. Let's see. Trying to see how they have them listed in the language reference. They have them. So there's some operators and other things that we're going to learn about later. There's a couple options. They're all under communication. Yeah, here we go. So communication, print, that's going to be the easiest starting point. For communication both into and back out to the user. There we go. So printing is what happens. It's a we can call it like a function. It is technically something called a class that allows output on different kinds of devices. Whether it's the serial monitor, LCD screen, actual physical printers, etc. There's a few libraries available to use. There's serial, there's liquid crystal, there's Ethernet, there's Wi-Fi. Specifically, what we're going to be doing is printing, but there's two varieties that are called print and print line. So you investigate both. What serial.print means is this will print human readable ASCII text to the actual serial monitor. So serial print of 78 gives the characters 78. Serial print of 1.23456 gives 1.23 as an output. Serial print n gives an outprint or printout of n. Serial print of hello world gives hello world in quotes. So these are fairly straightforward. You can also specify the output variety. We're not going to get into this right now because we don't need to for this simple example. But you can specify number of decimal places. You can translate to hex, decimal. You can transfer to an octal base, which is base 8. Decimal base is base 10, which is also the same unit system that we use. Then there's binary, which translates to ones and zeros. So they give an example here. And there's a couple kind of cool, tricky syntax things that we can do later. But for now, we just know that serial print takes it's a function that takes a value and a format or just a value. And we're going to start with this first example. There's also a serial print line. So we're going to go back, which is println. This one is more useful for our specific case because it prints human readable ASCII text followed by a carriage return. How many of you can actually tell me what a carriage return is? You guys even know what a carriage return is from? Anyone? Bueller. Nope. Carriage return. This is a reference from the day of typewriters when, in order to go to the next line, you had to hit a button that was the carriage return, which means type, shing, and it goes all the way back to the beginning, but it starts at the next line. That is a carriage return. So some of the language that still exists and some of the meaning that causes the syntax of the programming languages to be what it is comes from that era of typewriters, and there's problems and things to solve from that perspective. So that should allow for things to work in a very straightforward manner. It's a new term, and it's something that is not going to be super obvious, but it's something that we need to just be aware of. So there's some things like that. I'll try and point them out so that you guys don't come across them in an assignment or something and not have any context for them. So carriage return means go to the next line. Print line, println, means output the value and then have a return, or it's the equivalent of hitting the enter key to give you what's called a carriage return. So an example they give here is serial begin. So this is a thing that you have to do in order to open the serial port. 9600 baud is the default, so this is typically what you want to use as a reference rate. So we're going to have to do the same thing in the code that we're doing, but they start with an analog value, they do a read, then they do a serial print line, analog value, then they print using print line, analog value in decimal, analog value in hex, analog value in octal, analog value in binary. So this is an example of code that will print out interesting things. So first thing we have to do at some point in our setup, we will have to do this. So it makes sense to go ahead and include this, output, but you have to do this input. You have to do this first in order to do any of the other things that we're going to be looking to do. So really what we need to do is start the serial port. Then we need to begin by the way that we have our threshold. Switch to sharing this guy. So we have to start with our serial begin, because without that, we can't actually do, until we've done a serial dot begin, we can't actually get anything in or out from the serial port, so we can't actually ask the user questions. So serial dot begin, and for this, we do serial dot, and the fact that you guys have this many suggested helpers in the revised IDE makes life so much simpler. Print line is what we want, and it even offers a close parentheses for you, which is immensely helpful. So the question is going to be in the form of what's called a string data type. So it's going to be in quotes, and it's going to be serial print line, and we're going to say do you prefer gluten-free? We can just leave it at, do you prefer gluten-free? Then we need to do something with that. The reason that we can do this part of it in the setup is we don't need to ask the user over and over and over and over and over and over again if they prefer gluten-free. So then we need to do something that brings input in. So we got to go back to our language reference. And there's another serial function. And there's a couple ways to do it. We're going to do a read. So let's take a look at this. So there's another page in the language reference that's going to be helpful here. So serial.read. What this is going to do is we're going to have to tailor our question just a little bit to where set up serial.begin, if serial available. There's a couple pieces of the puzzle here that are going to be helpful. I'm not going to do This is a little bit more robust way of doing it. So I'll go ahead and include this. We're not going to focus on the if condition right now. The best way to think about this is this is basically a test that's built in. So we're going to learn about how to use these. This is a good example of how to do some testing in code. If serial is available, another thing that we're going to want to do in this that again is not something that shows up in our flow chart, but it's something that we need to do practically, is because humans don't operate like machines, you need to ask the question and give a few seconds for the person to respond, right? So we need a delay, and we need to say at least probably about 300 millisecond delay as a minimum. So this is let the user respond. This is how to check for a response.
Oh, may you switch to the code screen?
Yeah. Let me switch that. Downside of this particular software is real. Here we go.
Thank you so much.
So we've got, yeah, code is a very hard thing to imagine for a lot of reasons. So we have our comments telling us where we're headed, set up sandwich variables. We're nowhere near even using sandwich variables yet, but in the setup, this is all code that runs one time, and we only need it to run one time. We can get the input from this, and we can say, in this case, instead of incoming byte, what we're going to do is we're going to read in the bread type. Yeah, without doing conditional statements. This is going to be challenging to execute, but I want you guys to kind of see what it looks like, because there's a few steps to this, and we won't get anywhere near done with this program today, but we'll at least get a start to it. So this is yet another variable, and this is going to be bread type. So I'm going to use bread type because we've already got it. So bread type, it recognizes that this is a variable. It recognizes that it's one we're already using. And the two blue highlights tell you where that same variable is being used. So for troubleshooting, becomes immensely helpful. So bread type equal serial.read. So this is really reading the user input, serial.read. What we can do is simply say there's a couple different options for how to do a serial read. There is a serial read with a string match, so we could do yes or no. 1 or 0 is going to be easier for a lot of reasons for right now. So if yes, type 1. Otherwise, type 0. So this will print out all the stuff that is inside these quotes. So it will say, do you prefer gluten-free? If yes, type 1, otherwise type 0. So this will give our users an option to type 1 or 0. This is where we start to learn kind of some additional levels of things, because what if the user types the number 2 or 3? We're going to show how to handle that. And that's something called error handling, and we'll get into that in kind of a lot more detail later. So if yes, we're going to type 1, otherwise we're going to type 0. So assuming the user understands what that means, can read English, and so on and so on. There's a lot of assumptions there. Bread type equals serial read. Then, so this if opens and closes here. And this is just saying if serial is available, meaning if something has come back and there's not nothingness, then do whatever's inside of here. Do all of this stuff. Do all this stuff. So we're reading the user input. Then we need to compare what it is. And this is where it's a little bit tricky, but we need to do this in order to correctly sort the information. And this is why I said that 1 or 0 choice is not necessarily easier when we go to start writing a program on how all of this works. So we read the user input, we do a serial read, then we're going to do some serial printing, and that will help tremendously. So there's a couple things that'll help there. So say what you got instead of that. What we're going to do is we're going to sort the answer into yes or no at this step. So we're going to sort the answer into yes or no. And in this case, we're not going to do another serial print. We're going to there's also some clever combinations that you can do for a serial print and a serial print line, which means I received, and then a space, and then a value, and then it does a print line, meaning a return after it. So all of that happens on one line. We're not necessarily focused on that kind of level of cute right now. We just want to be able to compare. So for this, we're not using it for right now. So we're going to comment those 2 lines out. A lot of different ways to do that. I'm simply going to type a couple of slashes so that I don't need to use that piece right this instant. So what I'm going to do is set up another if, because I need to know what the user just gave back to me. So if we have to do another open and close. So I'm going to do that after this. So I'm going to open and close my if here. These are kind of helpful because these are going to help us sort out what kind of information we're dealing with, sort out whether values are large or small, lots of different things. We can index and understand if these are the right kinds of information. There's a lot of inquiry that we do using conditional statements like this in practice. So we're going to learn more about how to put these into practice. And tomorrow, I think we'll start with going to pseudocode from the flowchart to see why there's that progression, because trying to set this step up from the flowchart directly until you've actually started trying to do it, you don't recognize that your pseudocode needs to be more steps and more details. So this gets back to, do we have to be really specific on a flowchart? No, but the more specific that you are, the better prepared you're going to be when you go to write pseudocode for it and then write the actual program. Because we are still, even at this step, we're still at the very top of the chart with the very first decision tree about gluten-free. So we're already almost 30 lines of code just to do this decision tree at a start. So there's a lot that goes into the process, but it's simple logic to understand. So what we're looking at is if bread type is less than, if bread type is, we're going to say if bread type is, we'll do greater than 0 so that we can keep things neat and tidy. If bread type equal is 1, then what we're going to do is we're going to store in this comparison, we're going to say if bread type is greater than 0, the bread type is now going to be reassigned. So it's going to be now equal to our numeric value, which comes from our assignment. Wheat bread was 99. So if they say yes, and they type something other than 0, greater than 0, then bread type equals 99. Go to the next line. We can keep things, again, super duper simple. We're not doing layers of conditional statements. Here, I'm just going to try and do this as clearly and simply as possible. So we're sorting the answer if bread type is less than 1, i.e. if it's 0, then the bread type equals 44. This stores wheat bread to the variable, this stores this stores lettuce to variable. So keeping things super simple, super tidy. We'll find out some other ways to do this later. So I'm not trying to be inefficient with lines here. I'm trying to be crystal clear about what it is exactly that we're doing. So for this part, since we don't need the additional serial prints and serial print lines, I'm just going to delete those sections because we don't need them. So we have two conditions checking against two criteria to store the variable to one or the other. And now this has gotten us to where we understand how to store the information correctly to bread type. Okay, so in the algorithm, where we are now is there. So we have now crossed we have now done basically this portion of our algorithm. All right. So who thought that was going to be a whole lot easier than it was? Yeah, questions? We'll get into some of why we have to do that later, but I wanted you guys to see just how much it actually takes to get to this step. Okay? So it's not extreme, but in order to have user input and output, it actually takes a lot of logic and structure in order to store those things into memory so that we can use it later in the program. It takes some steps. We're going to learn more about why that is, why it works that way, how it works, all of those sorts of things. But I want you guys to be aware that, again, all of these people running around thinking that the AI is going to like erase humanity from the face of Earth. If it is this difficult to program something that is making a glorified ham sandwich, okay, the level and degree of difficulty writing an algorithm in order to take over the world is yeah, extreme. It's extreme. Also, the thing that you guys are noticing is the programs fundamentally have to have user input before they can do really anything at all. So these are really, really, really important concepts to understand, that programs, if they don't have user input, there's not a lot that they're always doing in the background. There can be processes, there can be calculations that they're running, all sorts of things, but there has to be some sort of structure that's put into place, and there has to be logic that is imposed on the system, and all of these layers of thought and understanding that goes into programming. You don't just sit down and start typing unless you're very, very experienced and you already have in your mind an approximate flow chart of where you're trying to head. So I don't even sit down in front of a blank code sheet and just rat-a-tat tap away and out pops magic out the other end. That is not a thing that happens. It requires thinking through setup. It requires thinking through these processes and understanding what's actually going on. So, all right, we have probably sufficiently melted your brain at this stage. Questions on this?
So right now, what we're doing, like with the code, is part 2 of the assignment.
Yes, so starting to do I think the actual assignment that you guys have up next is, so you have the algorithm design, and it's basically developing pseudocode from this. Then there's a couple other steps. So it's part 3 is pseudocoding. Part 1 is yeah, this one. Let me see what. So part 1 is really the way that this is written, there's kind of some overlap with the pseudocode. But yeah, one of them is looking for the pseudocode. One of them is looking for the actual code itself. So that's the part 1, the algorithm design. Arguably, that should be part 3, and part 2 should be pseudocoding. Part 1 should be flowcharting. I'm sure that'll get fixed in a future revision at some point. But the key there is these are things that we're trying to get you guys to start thinking through. Okay. So we've got flowcharting, we've got pseudocoding. We're going to talk a little bit more about pseudocoding later this week. So that should help to kind of set some additional boundaries to help make some of this make sense. Other questions?
If we're able to go back to the code that you were typing up, I have a question about that, as well as just the general like flow sheet. So for the flow sheet, designing the scenario for making the sandwich, is there a minimum amount of variables we need to establish, like a minimal amount of ingredients?
The minimum number of ingredients is 1 main ingredient. The version of the program that I'm helping to develop for you guys is going beyond the minimum requirements, because again, a lot of times you're going to have some kind of user that is trying to get off the algorithmic path and be distracted in all the details, or want your algorithm to do something that it doesn't already do, right? So people are always saying, well, it would just be great if this app would also do these 10 other things. And now you guys are starting to have an appreciation for why it's not as simple as just, you don't just drop in a feature. That's not really how stuff works. So there's a lot of steps and processes, and you have to have some plans in terms of software development.
Gotcha.
So we're trying to get you guys to think about how that might work. So we're going beyond the necessary scope of this assignment, because their example was how to print out 99 for 99 was an example of bread and whatever it was, chicken salad and bread, right? And that output would be an acceptable answer to this. I'm trying to start sort of stretching you guys a little further. It's like the pizza dough analogy. I stretch you much farther than you need to go so that when you relax and shrink and lose some stuff, the final size that you end up at is actually a very capable coder for basic operations. That's the goal for me. Okay.
Yeah. And does the like do the different ingredient types and like do the number inputs need to correlate with what is in the instructions for like the topic 1 part 1 type stuff? The like the ingredients wheat bread 99, lettuce 44. Do they need to be the same numbers?
So those need to be the same numbers based on being able to do output later. So the bread type, for instance, the all of those variables, those need to be able to be output as examples. So later on down here, the way that I'm setting up the algorithm, what we're effectively going to end up with is we've got this if that's happening. We're going to end up ultimately at the bottom with a serial print line for the last couple of pieces, but that's all going to be contained here within the setup. And for the way that I'm setting up the algorithm, I don't need the loop to run at all. So the loop is going to remain empty because I don't need to run code over and over and over again. The hard part about trying to include the other ingredients and having them select the other ingredients and doing it in a loop is now we need to learn about how to break loops and some other steps in there as well, because you can't just keep selecting ingredients forever because there's only physically so much that the bread can hold, right? So there's constraints in the real world that we also have to keep in mind in the code inputs and outputs. So a lot of moving pieces, a lot of new stuff that you guys have never really had to consider before. But this is why we're starting here, because it took all the way down to like line 32 effectively to get to where we had our first input actually saved to memory as a variable. So that's not uncommon, but it's just something to keep in mind. So we'll talk some more about a lot more details and what the pseudocode looks like, and then how to go from pseudocode to real code, because it'll be easier having started to set up some of the real code for you guys to see, oh, yeah, okay, for the pseudocode, I need a lot more detail than I need for the flowchart, right? Because the flowchart is big picture, what are we doing? The pseudocode is what are the steps to do those things. So some of those boxes might actually be 2 or 3 steps together, right? Like comparing, is this greater than 0 or less than 1, right?
Yeah.
So that's additional steps that should be accounted for in the pseudocode, but you don't think about that until you go to actually start putting that together. Then when you go to code it, the better you've done at the pseudocode step, the easier it's going to be to translate it into code. Does that help?
Yeah. And serial.begin 9600, does that mean anything in particular? Or is it just a rule?
So serial.begin 9600 is opening up the serial port on the Arduino. So any and all Arduinos, it's the exact same command. That opens up the USB port on it, which is the serial port. So universal serial bus, that's what that stands for. USB port that opens it up so that communication can happen both ways, and it sets the default speed at 9600, which both the computer and the Arduino then will understand, hey, we're agreeing to communicate at this speed. And 9600 is just the default, so there's not really a particular why, except that 9600 happens to work really well, it happens to be very low lag, and it's not memory intensive to run at that kind of speed. So, all right.
Awesome. Thank you.
All right. Well, if there's no other questions, then we will reconvene again on whatever that day is, Thursday. Yeah, that one.
Have a good day.
Yep, you guys too.
Have a good day.
Take care.